Welcome to Sleepless Philosophers, where deep ideas meet restful nights. If you enjoy these journeys through philosophy, please like and subscribe and turn on notifications for daily uploads. To support the channel, consider leaving a super thanks. Any amount helps us continue creating content. You can also become a member to request video topics. We're not monetized, so your support truly makes the difference. Now let the philosophy begin. Buridan's ass. When perfect balance creates perfect paralysis. A donkey stands exactly halfway between two identical bales of hay, equidistant from both. And the donkey is hungry, equally attracted to both bales. And both bales are identical in size, quality, freshness, and appeal. And there is no reason to prefer one over the other. No difference that would make choosing one more rational than choosing the other. And according to the principle of sufficient reason, the idea that every choice must have a reason, that rational action requires a reason to prefer one option over alternatives. The donkey cannot choose because choosing either bale would be arbitrary, would be action without sufficient reason, and so the donkey stands paralyzed, unable to move toward either bale, and eventually starves to death despite being surrounded by food. And this is Buridan's ass, a thought experiment in medieval philosophy, named after Jean Buridan, though the paradox predates him, and it illustrates a problem with certain models of rational choice, shows that if rationality requires sufficient reason for every choice, then perfect symmetry creates paralysis, creates situations where rational action becomes impossible. Imagine the donkey's perspective, looking left at one bale, looking right at the other, evaluating, comparing, and finding them perfectly equal. No basis for preference, no reason to go left rather than right or right rather than left. And the principle of sufficient reason says that to act rationally, the donkey needs a reason, needs something that makes one option better. And in the absence of such a reason, the donkey should not act, should remain neutral, should not arbitrarily favour one identical option over another. And so the donkey stays in place, and the bales remain equidistant, and time passes, and hunger grows, but still no reason emerges to break the symmetry. And the donkey, committed to rational decision-making, committed to acting only when there is sufficient reason, cannot move, and the commitment to rationality becomes a death sentence. The paradox challenges the principle of sufficient reason, challenges the idea that rational action always requires a reason to prefer one option over alternatives. Because in situations of perfect symmetry, there is no such reason, and yet acting is better than not acting. Choosing either balo is better than choosing neither, and survival requires breaking the symmetry. Somehow requires choosing arbitrarily, and if arbitrary choice is allowed, then the principle of sufficient reason is false, is not a requirement of rationality. And if arbitrary choice is not allowed, then rationality becomes self-defeating in symmetric situations, becomes a principle that prevents beneficial action, and neither option is attractive. Neither preserves our intuitions about what rationality requires. Visualize the situation as a balance, perfectly level, with equal weights on both sides, and the donkey as the fulcrum, unable to tip in either direction because the forces are equal. And tipping requires an imbalance, requires one side to outweigh the other, but no such imbalance exists, and so the balance remains level, and the donkey remains centered. And the metaphor captures the paralysis, the inability to move, when reasons are perfectly balanced, when no consideration favors one option over another. One response to the paradox is to deny that such perfect symmetry ever occurs in reality, to argue that there are always small differences, imperceptible perhaps, but sufficient to break ties. One bale is slightly closer or slightly greener, or catches the light differently. And even if these differences are too small to consciously notice, they provide sufficient reason for the unconscious decision-making processes that guide action, and so real donkeys never face perfect symmetry, never actually starve between identical bales, because nothing in nature is perfectly identical. And the paradox is a thought experiment that does not correspond to any actual situation. And while this may be true for physical objects, the paradox still applies to abstract choices, where perfect symmetry can be stipulated, and so the response avoids the real problem rather than solving it. Another response is to modify the principle of sufficient reason to allow arbitrary choice in symmetric situations. To say that rationality requires reasons to prefer one option over another when such reasons exist, but when options are genuinely equal, then arbitrary choice is rational, is indeed the only rational response. And in cases of perfect symmetry, choosing randomly is not irrational, but is the rational thing to do. And the donkey should flip a mental coin, should pick arbitrarily, should recognize that in the absence of reasons to distinguish between options, any choice is as good as any other, and making an arbitrary choice is better than making no choice. And this response preserves rationality while allowing action in symmetric cases. But it requires weakening the principle of sufficient reason, requires admitting that not all rational actions have reasons, that sometimes the rational thing is to act arbitrarily. A third response appeals to higher order considerations, argues that even when two options are equally good in terms of immediate outcomes, they may differ in terms of meta-level features, and the donkey should consider not just which bale to eat, but also principles of decision-making, and there are good reasons to have a policy of breaking ties somehow, perhaps always choosing the left option in symmetric cases, or always choosing randomly, and having such a policy provides sufficient reason to choose even when the options themselves provide no reason. And the donkey, who has adopted the policy of going left in symmetric situations, has a reason to go left. The reason is not that the left bale is better, but that the policy says to go left. And this preserves sufficient reason at a higher level while allowing action at the object level. But it raises questions about where the higher level policy comes from, whether adopting the policy itself requires sufficient reason, and whether we have just pushed the problem back one level without solving it. The paradox also connects to debates about free will and determinism, because if every choice requires a sufficient reason, a cause that explains why that choice was made rather than another, then in situations of perfect symmetry, no choice can be made. And yet humans and animals do make choices in such situations, do break ties, and this suggests that not all choices are determined by reasons, that there is some indeterminacy, some capacity for arbitrary choice, and libertarians about free will embrace this, argue that free will requires the ability to choose without sufficient determining reasons, requires that agents can tip the balance even when reasons are equal, but compatibilists and determinists argue that apparent symmetry is always broken by hidden factors, by unconscious preferences or random neural fluctuations, and what looks like arbitrary choice is actually determined by factors we do not consciously access. The paradox appears in practical contexts involving decision-making under uncertainty, where multiple options have equal expected value, and decision theory must specify what to do in such cases. And most theories say to choose randomly, to treat equal value options as interchangeable. And this is the rational response, but it requires abandoning the strong version of sufficient reason, requires accepting that rational choice sometimes is arbitrary choice, and this has implications for ethics and policy, for situations where multiple actions are equally good, where no moral consideration distinguishes between them. And in such cases, acting is better than paralysis, and any permissible action can be chosen without need for further justification. The donkey stands motionless, hunger gnawing, hay on both sides, and the commitment to sufficient reason becomes a trap, becomes a principle that prevents survival, and the paradox remains, challenging rationality, forcing recognition that reason has limits, that symmetry creates problems, that pure rationality cannot solve, that arbitrary choice, far from being irrational, is sometimes the only rational response. And Buridan's ass endures, starving between equal bales, a symbol of the perils of excessive rationality, of the dangers of demanding reasons when none exist. And the paradox persists as a reminder that action requires more than reason, requires the capacity to break ties, to choose when choices are equal, to act despite the absence of sufficient reason. And rational agents, whether donkeys or humans, must possess this capacity or risk paralysis. Risk standing frozen while opportunities pass and the ass remains. Hypothetical but instructive, teaching that rationality is not just about having good reasons, but also about knowing when reasons run out and arbitrary choice must begin. Zeno's dichotomy paradox. To reach a destination, one must first travel half the distance, and before reaching that halfway point, one must first travel half of that. And before reaching that point, one must travel half again. And this process of halving continues infinitely, and so it seems that motion cannot even begin, for there is always another halfway point that must be reached first. And this is Zeno's dichotomy paradox, one of the earliest and most famous arguments against the possibility of motion and change. Imagine a runner who wishes to cross a stadium. Before reaching the far end, they must reach the midpoint. But before reaching the midpoint, they must reach the quarter point. And before that, the eighth point, and so on, dividing the distance into ever smaller intervals without end. And since there are infinitely many such intervals, the runner would have to complete infinitely many tasks. And how can anyone complete an infinite number of tasks in a finite amount of time? And yet runners do cross stadiums. People do move from place to place. And so something must be wrong with the argument. But what? Zeno devised this paradox in the 5th century BCE to defend the philosophy of his teacher Parmenides, who claimed that reality is a single, unchanging unity, and that plurality and motion are illusions. And the dichotomy paradox was meant to show that the very concept of motion leads to absurdity, that if space and time can be divided infinitely, then movement becomes impossible, and therefore our perception of motion must be mistaken. Aristotle responded by distinguishing between potential and actual infinity, arguing that while the distance can potentially be divided into infinitely many parts, the runner does not actually traverse each part individually. The runner simply crosses the distance as a continuous whole, and the infinite division is something we can imagine, but not something the runner must perform. The paradox remained troubling for centuries, until the development of calculus in the 17th century by Newton and Leibniz, which provided mathematical tools to handle infinite sums and showed that an infinite series can converge to a finite value, 1/2 plus 1/4 plus 1/8, and so on adds up to exactly 1. And so the runner crossing infinitely many intervals in finite time is not a contradiction, but a mathematical fact. The sum of the infinite series equals the total distance, and the sum of the corresponding time intervals equals the total time. Yet some philosophers argue that the mathematical solution does not fully dissolve the conceptual problem, that even if the infinite series converges, there is still something mysterious about how an infinite process can be completed, how something that has no end can nevertheless reach an end, and whether the smooth continuous motion we experience is truly composed of infinitely many discrete steps, or whether motion is fundamentally continuous and indivisible. The paradox also raises questions about the structure of space and time, whether they are infinitely divisible, or whether there is a smallest possible unit of distance or duration, a quantum of space or time beyond which further division is meaningless. And modern physics has explored such ideas through quantum mechanics and theories of space-time foam, where the smooth fabric of reality may break down at extremely small scales. Zeno's dichotomy forces confrontation with infinity, with the strange fact that between any 2 points lie infinitely many other points, that the finite contains the infinite, that the continuous emerges from, or perhaps is the discrete, and that motion, the most familiar and undeniable aspect of existence, rests on foundations that are anything but solid. The runner crosses the stadium, the arrow flies, the universe moves and changes, and yet Zeno's voice echoes across the millennia, asking how, asking whether what seems so obvious might be impossible, whether the world we experience is the world that actually is, and whether reason and perception can ever be reconciled when one says motion is real and the other says motion leads to paradox. Yablo's paradox. In 1993, the philosopher Stephen Yablo introduced a paradox that seemed impossible, a self-referential contradiction that contains no self-reference at all, a loop without a loop. And this paradox has troubled logicians ever since because it challenges the assumption that all semantic paradoxes arise from statements referring to themselves. Imagine an infinite sequence of sentences, each one numbered, and each sentence says the same kind of thing. Sentence 1 says for all sentences, after this one, at least one of them is false. Sentence 2 says for all sentences, after this one, at least one of them is false. Sentence 3 says the same, and so on forever, each sentence making a claim about all the sentences that come after it, but never referring to itself or to any sentence that comes before. Now consider whether sentence 1 is true. If it is true, then at least one sentence after it must be false. So sentence 2 or 3 or some later sentence must be false. But sentence 2 makes the same claim as sentence 1, just shifted down the sequence. So if sentence 2 is false, then all sentences after it must be true. But sentence 3 says at least one sentence after it is false, which contradicts the idea that all sentences after sentence 2 are true, and so sentence 2 cannot be false. And the same reasoning applies to every sentence in the sequence. None of them can be false without contradiction, which means all of them must be true. But if all of them are true, then sentence 1's claim that at least one sentence after it is false must itself be false, and so we arrive at a contradiction without any sentence ever referring to itself. The paradox is startling because it was long believed that self-reference was the root of all semantic paradoxes, that statements like this sentence is false create problems precisely because they loop back on themselves. But Yablo's paradox suggests that infinite chains of reference can generate the same kind of contradiction, even when each individual sentence only points forward, never backward. Some philosophers argue that Yablo's paradox is secretly self-referential after all, that the infinite sequence as a whole refers to itself in some implicit way, or that each sentence indirectly refers to itself through the mediation of the sentences that follow. But others insist that the paradox is genuinely non-self-referential, that it reveals a new kind of logical pathology that cannot be explained by the old models. The paradox has deep implications for theories of truth, because if self-reference is not necessary for paradox, then many proposed solutions to the liar paradox and related problems must be reconsidered, and new strategies must be developed to handle infinite structures that generate contradiction through endless forward reference, rather than immediate loops. Some logicians suggest that the paradox arises because we are treating an infinite sequence of statements as if it were a completed whole, and that in a finite or constructive framework, the paradox would dissolve, while others embrace infinitary logic and try to develop formal systems that can accommodate Yablo's structure without collapsing into inconsistency. The paradox also connects to issues in recursion theory and computer science, where infinite loops and non-terminating processes can exhibit similar behavior, generating contradictions or undefined results, without any single step referring back to a previous one. Yablo's paradox stands as a reminder that infinity is strange, that logic stretched across endless sequences behaves in ways that defy intuition, and that the boundaries of coherent thought may be more fragile than we imagined, that even without the familiar twist of self-reference, language and logic can still tie themselves into knots from which there is no escape. Zubov's paradox, a thought experiment in personal identity, asks us to imagine a machine that can instantly create a perfect duplicate of a person, atom by atom, molecule by molecule, and the duplicate is placed in a different location, perhaps on Mars while the original remains on Earth, and both individuals emerge from the process with all the same memories, the same personality, the same sense of being the person who entered the machine. And now the question arises, which one is the real person? Which one continues the original stream of consciousness? And Zubov's paradox, presented by Arnold Zuboff, pushes this scenario further by asking what happens if the duplication process creates not just one copy, but many copies, perhaps millions, all scattered across the universe, all emerging simultaneously with the same memories and the same conviction that they are the original person. And the paradox is that if one copy preserves personal identity, then it seems that all copies should preserve it. But if all copies are the original person, then identity has become plural. One person has become many. And this seems to violate the transitivity and uniqueness of identity. The principle that identity is a one-to-one relation, that if A is identical to B and A is identical to C, then B must be identical to C. But if millions of copies all claim to be the original person and none has a privileged status, then they cannot all be numerically identical to each other. They are distinct individuals occupying different locations. And so, identity seems to have been destroyed or multiplied in ways that make no sense. The paradox challenges the intuition that psychological continuity is sufficient for personal identity. The view associated with John Locke and Derek Parfit that what makes a future person the same person as a present person is the continuity of memories, personality, beliefs, desires, and other psychological characteristics. And this view seems plausible when considering ordinary cases of survival through time. The person who wakes up tomorrow is the same person who went to sleep tonight, because there is psychological continuity, but the duplication case shows that psychological continuity cannot be sufficient for identity because identity is one-to-one, while psychological continuity can be one-to-many. Multiple future individuals can all be psychologically continuous with a single past individual, and if we say that only one of them is the original person, then we need a criterion to distinguish that one from the others. And no such criterion seems available if all the copies are physically and psychologically identical. Zuboff's contribution is to emphasize the symmetry of the situation. When there are multiple copies and no physical or psychological differences between them, there is no non-arbitrary way to select one as the original, and the others as mere copies, and if we are forced to say that none of them is the original, that personal identity was destroyed by the duplication process, then we must accept that identity is incompatible with duplication, that what matters for survival is not just psychological continuity, but also the absence of competitors, the requirement that there be, at most, one future individual who is psychologically continuous with the present individual. And this requirement seems strange, seems to make identity depend on what happens to other people, on whether duplicates exist rather than on intrinsic facts about the individual's own physical and psychological continuity. The paradox connects to debates about what matters in survival. Parfit argued that identity is not what matters, that what we care about when we care about survival is not numerical identity, but psychological connectedness and continuity. And if these can be preserved and even multiplied, then we should regard that as a good thing, as a kind of proliferation of what matters, rather than a loss of identity. And Parfit bit the bullet, accepting that in duplication cases, the original person does not survive as a single individual, but survives in a broader sense as multiple individuals, each with equal claim to being a continuation of the original. And this view dissolves the paradox by rejecting the assumption that survival requires identity, but it strikes many people as counterintuitive, as a refusal to take seriously the distinctness of persons. The fact that I am one person, not many, and that survival means that I, this particular individual, continue to exist. not that some psychologically similar individuals exist. Others have proposed that identity in duplication cases is vague or indeterminate, that there is no fact of the matter about which copy, if any, is the original, that identity admits of degrees or borderline cases, and this indeterminacy is not a sign of ignorance, but a feature of the metaphysics, a reflection of the fact that identity is a coarse-grained concept that breaks down in cases involving fission or duplication. And while this response accommodates the intuition that duplication creates a puzzle, it does so by accepting that some questions about identity have no determinate answers, and this itself is a controversial metaphysical commitment. Still, others distinguish between survival and identity, arguing that survival is a looser relation than identity, that survival can occur without identity if there is sufficient continuity and connectedness, and that in duplication cases, all the copies survive, even though none is identical to the original. And this view preserves the one-to-one nature of identity, while allowing that what we care about, survival, can be a one-to-many relation, and it provides a framework for thinking about duplication that does not force us to choose between denying continuity matters or accepting the multiplication of identity. Zubov's paradox also has implications for practical ethics, for questions about the permissibility of creating duplicates, about whether duplicating a person harms them or benefits them or does neither, about whether the duplicates have the same rights and responsibilities as the original, and about how to distribute resources or assign credit and blame when multiple individuals all have equal claim to being the continuation of a single person. And these questions have no obvious answers. They require rethinking fundamental assumptions about personhood, autonomy, and moral status. The duplication machine hums. The original person steps inside, and moments later, millions of copies emerge across the universe, each one waking with the conviction that they are the person who entered the machine, each one feeling the continuity of consciousness, the persistence of memory, the seamless transition from before to after. And yet, something has changed. Identity has fractured or multiplied or disappeared, and the paradox asks what has happened, what it means to survive when survival takes this form, and the answers do not come easily. They require choosing between intuitions that cannot all be preserved, between the importance of identity and the importance of continuity, between the uniqueness of persons and the possibility of multiplication. And Zubov's paradox remains a powerful challenge to theories of personal identity, a thought experiment that exposes tensions and forces choices, and it endures as a puzzle that has no consensus solution, no answer that satisfies all intuitions, only a set of options, each with costs, each requiring the abandonment of something we thought was certain, and the copies live their lives, scattered across space, each believing themselves to be the original, and perhaps they are, or perhaps none of them are, or perhaps the question has no answer, and the paradox persists, unresolved, a permanent feature of the landscape of personal identity, a reminder that who we are, what it means to survive, what it means to be the same person over time, are questions that remain open, that resist final answers, and that become stranger and more perplexing the more carefully we examine them. Gettier problems. For over 2,000 years, philosophers believed they had a satisfactory definition of knowledge, tracing back to Plato's dialogue Theaetetus, and this definition stated that knowledge is justified true belief, that to know a proposition, 3 conditions must be met. The proposition must be true, the believer must believe it, and the believer must have good reasons or justification for believing it. And this tripartite analysis seemed to capture what knowledge is, to distinguish genuine knowledge from lucky guesses, false beliefs, and unjustified opinions. And the definition was widely accepted, taught in textbooks, treated as settled wisdom, until 1963, when a philosopher named Edmund Gettier published a 3-page paper that shattered this consensus and transformed epistemology. Gettier presented cases, now known as Gettier problems or Gettier cases, where all 3 conditions for knowledge are satisfied, and yet intuitively the person does not have knowledge, where justified true belief is present but knowledge is absent. And these cases show that the traditional definition is insufficient, that something more is needed, though what that something is remains a matter of intense debate. The structure of a Gettier case typically involves a person who has a justified belief that happens to be true, but is true for reasons unrelated to the justification, where the justification is somehow defective or based on a falsehood, yet the belief turns out to be true by luck or coincidence. And this combination of justification and truth without the right kind of connection between them produces cases where we hesitate to attribute knowledge. Consider one of Gettier's original examples. Smith and Jones have applied for a job, and Smith has strong evidence that Jones will get the job. The president of the company told him so, and Smith also knows that Jones has 10 coins in his pocket. Smith counted them, and from these 2 pieces of evidence, Smith infers that the person who will get the job has 10 coins in his pocket, and this inference is justified. It follows logically from what Smith believes he knows. But unbeknownst to Smith, it is actually Smith himself who will get the job. The president was mistaken or changed his mind, and by an extraordinary coincidence, Smith also has 10 coins in his pocket. And so Smith's belief that the person who will get the job has 10 coins in his pocket is true, and it is justified based on apparently good evidence. And yet Smith does not know this truth, because his belief is true for the wrong reasons, true because of a coincidence, rather than because of the facts that justified it. Another classic example involves a person looking at a clock. The clock reads 3 o'clock, and the person forms the belief that it is 3 o'clock. And this belief is justified because clocks are generally reliable sources of time information. But unbeknownst to the person, the clock stopped exactly 12 hours ago and just happens to be showing the correct time again. And so the belief is justified and true, but does not constitute knowledge because the truth is accidental, unconnected to the reason for belief. Gettier cases have proliferated. Philosophers have constructed hundreds of variations, each designed to test different theories of knowledge, each revealing new wrinkles in the concept, and the common thread is that the justification and the truth come apart. The belief is true, but not because of the justification, or the justification is based on a falsehood that happens to lead to a true conclusion, or the truth obtains for reasons the believer is unaware of. And in all these cases we feel that something is missing, that the person has justified true belief but lacks knowledge. The philosophical response to Gettier has been to add a 4th condition to the definition of knowledge, to supplement justified true belief with some additional requirement that rules out Gettier cases, and many such conditions have been proposed. Some argue for a no false lemmas condition, requiring that the justification not depend on any false beliefs, so that in the job case Smith's reasoning depended on the false belief that Jones would get the job, and this false lemma disqualifies the belief from being knowledge even though the conclusion is true. But this condition faces problems, because not all Gettier cases involve false lemmas. Some involve true beliefs that are justified by faulty processes or that happen to be true by luck without depending on any particular false intermediate belief. Others propose causal theories of knowledge, requiring that the belief be caused in the right way by the fact that makes it true, that there be a causal connection between the truth and the belief. And this would rule out the clock case, because the fact that it is 3 o'clock is not causally responsible for the clock showing 3 o'clock. The clock shows that time because it stopped 12 hours ago, not because it is currently 3 o'clock. But causal theories struggle with cases involving abstract objects or mathematical truths, where causal connections seem inappropriate or impossible. Reliabilist theories propose that knowledge requires belief to be produced by a reliable process, a process that generally produces true beliefs. And this seems to handle many Gettier cases because the processes involved, like inferring from false beliefs or reading stopped clocks, are not reliable even if they happen to produce true beliefs in particular instances. But reliabilism faces the generality problem, the question of how to specify which process is operative in a given case, because any belief is produced by many processes at different levels of generality, and depending on how the process is described, it may be reliable or unreliable. Safety and sensitivity conditions have also been proposed. Safety requires that in nearby possible worlds, where the person still believes the proposition is still true, that the belief could not easily have been false. And sensitivity requires that in nearby worlds, where the proposition is false, the person would not believe it. And these modal conditions attempt to capture the idea that knowledge requires a stable connection between belief and truth, a connection that holds not just in the actual world, but in close counterfactual situations, but both conditions face counterexamples and refinements continue. Virtue epistemology offers another approach, suggesting that knowledge requires belief to be produced by the exercise of intellectual virtues, by cognitive abilities and skills that are credit to the agent. And on this view, Gettier cases fail to be knowledge, because the truth of the belief is not attributable to the cognitive abilities of the believer, but to luck or coincidence. But this raises questions about how to individuate abilities, about what counts as an exercise of skill versus a lucky outcome, and about whether knowledge really requires that the believer deserve credit for getting things right. The debate over Gettier cases has dominated analytic epistemology for over 60 years, generating thousands of papers, dozens of theories, and no clear consensus. And some philosophers have begun to question whether the project of defining knowledge in terms of necessary and sufficient conditions is misguided, whether knowledge is a natural kind with sharp boundaries, or whether it is a cluster concept, a family resemblance term that cannot be captured by a precise definition. And experimental philosophers have tested intuitions about Gettier cases across different cultures and demographics, finding some variation and raising questions about whose intuitions should guide philosophical theorizing. Gettier's legacy is immense. His 3-page paper demolished a definition that stood for millennia and launched an industry of epistemological research. And while the original problem, finding necessary and sufficient conditions for knowledge, remains unsolved, the attempt has deepened our understanding of justification, truth, belief, luck, causation, and the complex relationships between them. And Gettier cases continue to serve as test cases for theories of knowledge, as benchmarks that any adequate theory must handle. And they remind us that even our most basic concepts, even something as central as knowledge itself, are more complex and more elusive than they first appear, that definitions are hard to come by, that counterexamples lurk around every corner, and that the philosophical quest for clarity and precision is never-ending, always encountering new obstacles, new puzzles, new reasons to question what seemed settled. And Smith stands there with his 10 coins, believing truly and with justification that the person who will get the job has 10 coins in his pocket, and yet he does not know. And this simple case, this small story about a job and some coins, contains within it a challenge that philosophy has not yet met, a puzzle that refuses to be solved, a gap between justified true belief and knowledge that no fourth condition has successfully closed, and the search continues. Philosophers proposing new theories, new conditions, new ways of understanding what knowledge is and what distinguishes it from mere lucky true belief. And Gettier watches from beyond the grave, his 3 pages having accomplished what few philosophical works ever do, fundamentally reshaping the discipline, forcing a rethinking of basic assumptions, proving that even ancient wisdom is vulnerable to counterexample, and that the road to philosophical truth is longer and more winding than we imagined. Epimenides' paradox. A poet from Crete named Epimenides once declared that all Cretans are liars, and this statement, simple as it seems, has echoed through the centuries as one of the earliest recorded paradoxes, a puzzle that predates even the formal study of logic, and yet contains within it the seeds of contradictions that still trouble philosophers today. If Epimenides himself is a Cretan and he claims that all Cretans are liars, then his statement must be a lie. But if his statement is a lie, then not all Cretans are liars, which means some Cretans tell the truth, which could include Epimenides himself, which means his statement might be true after all, which means all Cretans are liars, which means his statement is a lie and the cycle begins again. The paradox is not quite as airtight as the liar paradox that would emerge later, because calling someone a liar does not mean they always lie, only that they lie sometimes. And so there remains a sliver of logical escape, a possibility that Epimenides is telling the truth on this one occasion while still being a liar in general, or that his statement is partially true and partially false, depending on how it is interpreted. St. Paul referenced the paradox in his letter to Titus, quoting Epimenides and adding that the statement is true, seemingly unaware or unconcerned with the logical contradiction embedded in his endorsement. And this has led to centuries of theological and philosophical debate about what Paul intended and whether Scripture itself contains a paradox. The ancient Greeks recognized the puzzle but lacked the formal tools to fully analyze it, treating it more as a rhetorical curiosity than a serious threat to logic. And it was not until the development of modern symbolic logic that the deeper implications became clear. The paradox belongs to a family of self-referential statements that collapse under their own weight, and Bertrand Russell would later use variations of this structure to reveal cracks in the foundation of mathematics, proving that not all sets can be safely defined, that not all statements can be assigned a truth value without contradiction. Some philosophers argue that the Epimenides paradox is weaker than its descendants because it depends on empirical facts about Cretans rather than purely logical structure, and that if we simply reject the premise that all Cretans are liars, the paradox dissolves, unlike the pure liar paradox which creates contradiction through its form alone. Others see it as an early recognition that language can turn against itself, that statements about truth and falsehood require careful handling, that self-reference introduces dangers that must be acknowledged and navigated. The paradox also raises questions about identity and generalization, about what it means to make sweeping claims about groups of people, and whether such claims can ever be fully coherent when the speaker is part of the group being described. Epimenides stands at the origin of a long tradition of logical puzzles, his words reverberating through time. A poet who may not have fully understood what he had unleashed, but who nevertheless gave voice to one of the fundamental tensions in human thought, the way that truth can fold back on itself and become strange, unstable, uncertain. Goodman's Grue paradox. When emeralds turn blue at midnight, a philosopher invents a new colour term, grue, and grue is defined as follows. An object is grue if it is observed before time t and is green, or if it is not observed before time t and is blue, where t is some future date, perhaps January 1st of next year. And this definition is strange, is artificial, combines observation and time in a way that ordinary colour terms do not. But the definition is precise, is perfectly clear. And now the philosopher considers emeralds and notes that all emeralds observed so far have been green. And these observations support the hypothesis all emeralds are green. And the same observations also support the hypothesis all emeralds are grue because all observed emeralds satisfy both descriptions. They are green, which means they are grue up to time t, and both hypotheses are equally well supported by the evidence. Both fit all observations perfectly, and yet the two hypotheses make different predictions about the future. The first predicts that emeralds examined after time t will be green. The second predicts they will be blue. And so we have two hypotheses, equally supported by evidence, making opposite predictions. And the question is, which hypothesis should we believe? Which generalization should we project into the future? And Nelson Goodman poses this as a problem about projectability, about which predicates can legitimately be used in inductive inferences. And this is the GRU paradox, also called Goodman's new riddle of induction, a puzzle that shows that not all evidence-supported hypotheses are equal, that some predicates are projectable and others are not, and the challenge is to explain what makes green projectable and GRU not, what distinguishes legitimate from illegitimate generalizations. Imagine living in a world where emeralds are GRU, where all emeralds observed before time t are green, but all emeralds examined after time t are blue. And from the perspective of someone before time t, this is indistinguishable from a world where emeralds are simply green. All observations are the same, and yet the two worlds are radically different, will diverge dramatically after time t. And the puzzle is that evidence accumulated before t does not distinguish between these possibilities, does not tell us which world we inhabit, and so induction alone cannot determine which hypothesis to accept, cannot tell us whether emeralds are green or GRU. And this reveals that induction requires more than just fitting evidence, requires principles about which predicates are projectable, which generalizations are legitimate. And these principles cannot themselves be justified inductively without circularity. Visualize the timeline with time t marking a boundary, and on one side of the boundary, all observed emeralds are green. And the question is what happens after the boundary. Do emeralds remain green, or do they become blue? And the hypothesis, all emeralds are GRU, says they switch colours. But this switching is built into the definition of GRU, is a feature of how the predicate is defined rather than a feature of emeralds themselves. And this reveals something important, that the GRU hypothesis is gerrymandered, is artificially constructed to fit past observations while making a different prediction about the future. And our intuition is that such gerrymandered hypotheses should not be projected, should not be taken seriously, but explaining why requires articulating a principle that distinguishes natural from gerrymandered predicates. Goodman's own solution appeals to entrenchment, argues that green is projectable because it has been used successfully in many past inductions, has become entrenched in our language and our theories, while GRU is a newcomer, is defined artificially, has no history of successful projection, and so we should prefer green over GRU, not for any logical reason, but for pragmatic reasons, because green has proven its worth. And this solution ties projectability to linguistic and scientific practice, makes it a matter of history rather than logic. And some find this unsatisfying, find it too relativistic. But Goodman argues that there is no deeper justification available, that entrenchment is as good as justification gets for inductive inference. Another response argues that GRU is not a genuine predicate, is not natural, because it is defined in terms of observation and time, includes reference to specific moments and observers, and genuine properties should be observer independent, should not change based on when or whether they are observed. And green is natural in this sense, refers to a real property that objects have regardless of observation, while GRU is artificial, is defined through disjunction and reference to observation, and so only natural predicates are projectable. And this solution requires explaining what makes a predicate natural, what distinguishes genuine properties from artificial constructions. And this leads to metaphysical questions about the nature of properties, about whether naturalness is objective or conventional. A third response from a Bayesian perspective argues that GRU hypotheses are less probable than green hypotheses given reasonable priors, because GRU hypotheses postulate discontinuities, postulate that properties change suddenly at arbitrary times, and such discontinuities require explanation, require reasons, and in the absence of such reasons we should assign low prior probability to GRU hypotheses. And so while GRU fits the evidence as well as green, GRU is less probable overall because of its lower prior, and this solution appeals to simplicity and parsimony, treats continuous properties as more probable than discontinuous ones, and explains projectability in terms of prior probabilities rather than entrenchment or naturalness. The GRU paradox also reveals that the problem of induction is deeper than Hume recognised, because Hume worried about justifying any inductive inference, about showing that the future will resemble the past. But even if we accept induction, we face Goodman's problem. We must choose which respects the future will resemble the past, must decide which predicates to project, and different choices lead to different predictions. And there is no algorithm, no mechanical procedure that tells us which predicates are projectable, which generalizations are legitimate. And so induction requires judgment, requires background knowledge, requires engagement with the actual practice of science rather than pure logical analysis. The paradox extends beyond emeralds and colours to any inductive inference, to all attempts to generalize from observed to unobserved cases, because for any pattern we observe, for any regularity we find, there are infinite GRU-like predicates that fit the pattern up to now, but diverge in the future, and choosing between these predicates cannot be done on evidential grounds alone, requires additional principles, requires distinguishing projectable from non-projectable predicates, and every scientific theory makes such choices, implicitly assumes that certain predicates are natural and others artificial, and Goodman's paradox makes these assumptions explicit, forces recognition that induction is not just about fitting evidence, but about choosing the right vocabulary, the right predicates, the right way of carving up the world. The clock approaches time T, and emeralds remain green, as they always have been, and the GRU hypothesis is refuted, is shown to have been wrong. But before time T, the evidence supported GRU as much as green, and this shows that evidence alone was insufficient, that something beyond evidence guided our preference for green, our confidence that emeralds would remain green rather than turning blue, and that something is what Goodman's paradox investigates, what it challenges, used to articulate, and the paradox remains not fully resolved, not answered by any single theory that satisfies everyone, but persistent as a challenge to theories of induction, a test case for accounts of scientific reasoning, and a reminder that generalizing from experience requires more than logic, requires substantive assumptions about the world, about which properties are real and which are artificial, about which patterns will continue and which will break. And these assumptions cannot be justified inductively without circularity, cannot be proven logically without begging the question. And so induction rests ultimately on judgment, on practices that have proven successful, on entrenchment or naturalness or simplicity. And Goodman's GRU paradox reveals this foundation, exposes the principles we rely on but cannot fully justify. And the paradox endures as one of the most important problems in philosophy of science. Laplace's demon, the mind that knows everything that will ever happen. A supremely intelligent being, a vast intellect that knows the position and velocity of every particle in the universe at a single instant, stands outside time and space. And this being, this demon, as Pierre-Simon Laplace called it in 1814, possesses the complete laws of physics, the equations that govern how particles interact and move, and with this information, the precise state of every atom and the exact rules of motion, the demon can calculate the future, can determine with perfect accuracy where every particle will be at any future time, can predict every event, every thought, every decision, every outcome, from the fall of a raindrop to the rise of civilizations, from the collision of atoms to the death of stars. And in principle, the demon could also calculate the past, could trace every particle's trajectory backward to determine exactly how the present arose from previous states. And so this demon, given sufficient computational power, could know everything that has happened and everything that will happen. the entire history of the universe, past and future, encoded in a single snapshot of the present. And this is Laplace's demon, a thought experiment about determinism, about whether the universe is a clockwork mechanism, where the future is entirely determined by the past, where free will is an illusion, where everything that will ever happen is already decided, already implicit in the current state of things. Imagine the demon's knowledge as a vast table, infinitely long, listing the position and velocity of every particle, every electron, every quark, every photon, trillions upon trillions upon trillions of entries, and the demon has access to all this information perfectly, knows it exactly, with infinite precision. And the demon also knows Newton's laws, or perhaps Einstein's field equations, or quantum mechanics, knows the rules that govern how these particles influence each other, how forces propagate, how energy transfers, and with this knowledge, the demon can simulate the universe, can run the equations forward in time, calculating step by step how the particles will move, how they will collide and interact, and the simulation produces a prediction, a complete specification of the universe at every future moment. And this prediction, if the laws of physics are deterministic, is not probabilistic but certain. The future is determined, fixed, inevitable, and the demon knows it all. The implications are profound and troubling, because if Laplace's demon is possible, if the universe is deterministic, then free will becomes problematic, becomes perhaps an illusion, because every decision you make, every thought you have, every action you take is the result of particles in your brain following physical laws, and those particles are moving according to rules determined by their initial conditions, and those initial conditions were set by earlier states, going back to the beginning of the universe. And so your choices are not free but predetermined, decided billions of years ago when the universe began, and you are not an agent but an automaton, a complex machine that operates according to fixed rules, and the feeling of making choices, of deliberating and deciding, is a subjective experience produced by computational processes in your brain. But the outcome was never in doubt, was determined from the start, and this conclusion undermines moral responsibility, undermines the concepts of praise and blame, undermines the notion that people could have done otherwise, and it raises the question of what it means to be human if our actions are all predetermined. But Laplace's demon faces several obstacles, several reasons why even in principle it might be impossible. The first obstacle is quantum mechanics, which was unknown in Laplace's time, but is now recognized as fundamental to physics, and quantum mechanics is probabilistic, not deterministic. The Heisenberg uncertainty principle states that we cannot know both the position and velocity of a particle with perfect precision. There is an irreducible indeterminacy, a fundamental limit on what can be known, and when we measure a quantum system, the outcome is random, governed by probabilities but not determined. And so Laplace's demon cannot have the precise initial conditions it needs, cannot know the exact state of the universe, and even if it could, the laws of quantum mechanics only predict probabilities for future events, not certainties. And so the future is genuinely open, not determined, and Laplace's demon is impossible. The second obstacle is chaos sensitivity to initial conditions, where tiny unmeasurable differences in starting states lead to vastly different outcomes over time. Weather systems, planetary orbits, fluid flows, all exhibit chaotic behavior, where prediction becomes impossible beyond a certain time horizon, because errors in measurement, no matter how small, grow exponentially and eventually dominate. And even if quantum mechanics were not an issue, even in a classical deterministic universe, practical prediction would be impossible for chaotic systems, and the demon would need infinite precision, infinitely accurate knowledge of initial conditions, and any finite approximation, no matter how good, would fail after sufficient time. And so the demon's predictions would be useless for complex systems on long timescales. The third obstacle is computational. Even if the demon had perfect information and deterministic laws, simulating the universe requires computing power, requires processing the interactions of every particle, and the universe contains roughly 10 to the 80 particles, and computing their evolution requires resources, and some physicists have argued that simulating the universe would require a computer as large as the universe itself, and such a computer could not run faster than the universe it simulates, could not predict the future faster than the future unfolds. And so the demon could not tell you tomorrow's events before tomorrow arrives, and the demon becomes useless as a predictor, reduced to a mere recorder that reconstructs what has already happened rather than foretelling what will happen. Visualize the universe as a vast machine, gears turning, particles moving, and Laplace's demon standing outside, watching the machine, knowing the position of every gear, the velocity of every component, and calculating how the machine will continue to turn. But the demon is blocked by quantum uncertainty, cannot measure the gears precisely enough, is blocked by chaos, cannot maintain accuracy over time, is blocked by computational limits, cannot perform the calculation fast enough. And so the demon, mighty as it seems, is impossible. The universe resists total prediction, resists complete knowledge, not because of practical limitations, but because of fundamental features of physical law and determinism. Even if it were true, does not grant us the power to predict. And the demon remains a thought experiment, a symbol of a kind of knowledge that cannot exist, a vision of omniscience that is ruled out by the nature of reality itself. Laplace's demon also raises philosophical questions about explanation and understanding, because even if we cannot predict the future, even if determinism fails or the demon is impossible, we still seek to explain why things happen, to trace causes and effects, to understand the mechanisms that generate events. And this explanatory project does not require Laplacian determinism, does not require perfect prediction, but only patterns, regularities, laws that hold approximately, and science proceeds without the demon, without omniscience, by finding partial explanations, probabilistic models, statistical regularities, and these are sufficient for understanding, for technology, for navigating the world. And the demon's impossibility does not doom science but liberates it, frees it from the burden of total prediction, allows it to focus on what can be known rather than lamenting what cannot. The demon sits in conceptual space, all-knowing and impotent, knowing everything but unable to act, unable to exist, blocked by uncertainty, by chaos, by computation, and Laplace's vision of a deterministic clockwork universe fades, replaced by a more subtle picture, a universe governed by laws but not wholly determined, open to chance, to randomness, to emergence, where the future is not written in the present but unfolds through processes that are partly lawful and partly random, and free will, though not proven, is at least not obviously refuted, and moral responsibility, though challenged, survives because even if determinism were true, even if all actions are caused by prior states, we still distinguish between actions that flow from deliberation and those that do not, between agents who respond to reasons and those who do not, and these distinctions matter, ground our practices of praise and blame, and Laplace's demon, impossible and paradoxical, remains a touchstone in debates about determinism, free will, and the limits of knowledge, a thought experiment that has shaped centuries of discussion and continues to challenge our understanding of what it means to predict, to know, and to be free. McTaggart's paradox of time, why past, present, and future are contradictory. A philosopher named J.M.E. McTaggart constructs an argument attempting to prove that time is unreal, that temporal distinctions are contradictory, that past, present, and future cannot coexist, and the argument begins by distinguishing two ways of thinking about time: the A series, which orders events as past, present, or future, and the B series, which orders events as earlier than or later than each other, And McTaggart argues that the A-series is essential to time, that change requires events to move from future to present to past, that without this passage, without the A-series, there is no real time. But the A-series is contradictory, generates logical problems, and therefore time is unreal, is an appearance generated by our temporal perspective, but does not correspond to ultimate reality. And this is McTaggart's paradox of time, one of the most famous and most controversial arguments in the philosophy of time, an argument that has shaped all subsequent debates about the nature of time, about whether time is real or illusory, about whether the passage of time is objective or subjective. Imagine time as having two aspects: the A-series aspect where events are classified as past, present, or future, where we say the meeting is future, is happening now in the present, was past yesterday, and events change their A-series position, move from future to present to past, and this movement is time's passage, is what makes time dynamic. And the B-series aspect where events are ordered as earlier or later, where we say the meeting is later than breakfast and earlier than dinner, and these B-series relations are fixed, do not change. The meeting is always later than breakfast, regardless of when we consider it. And McTaggart argues that the A-series is essential for real time, that the B-series alone is not sufficient, that time requires passage, requires events to change from future to present to past, but the A-series is contradictory, and so time is impossible, is unreal. The paradox emerges from the fact that A-series properties are contradictory. Every event is past and present and future. The meeting is future before it occurs, is present when it occurs, is past after it occurs. And so the meeting has all three properties, is past and present and future. And these properties are incompatible, cannot all be instantiated by the same event. And so the A-series generates contradiction. And the standard response is to say that events have A-series properties at different times. The meeting is future at earlier times, present at its time of occurrence, past at later times. And this seems to resolve the contradiction by indexing A-series properties to times. But McTaggart argues this does not help, because now we must ask whether the times themselves are past, present, or future. And the same problem recurs. If the time at which the meeting is future is itself past, then the meeting is past and future, and contradiction remains. And indexing to times does not eliminate the contradiction, but only pushes it back. McTaggart argues that the only way to avoid contradiction is to eliminate the A-series, to accept that events do not really move from future to present to past. That passage is illusory, that reality consists only of the B-series, only of earlier-later relations. But the B-series without the A-series is not real time, is only a static ordering, lacks the dynamism, lacks the passage that is essential to time. And so time is unreal, is an appearance that our consciousness generates from a fundamentally timeless reality. And McTaggart's position is a form of idealism about time, treats time as mind-dependent, as not part of the ultimate structure of reality. Visualize the paradox as a vicious circle. Events have A-series properties, but these properties are contradictory. So we index them to times, but then times have A-series properties, which are contradictory. So we index to second-order times, but these are contradictory, and the regress continues. And the contradiction is never eliminated, only relocated. And McTaggart concludes that the A-series is inherently contradictory, cannot be made coherent, and must be rejected. And with it goes time itself, which requires the A-series for its reality. One response to McTaggart's paradox, the tenseless or B-theory response, accepts McTaggart's argument that the A-series is contradictory, but denies that time requires the A-series, argues that the B-series is sufficient for real time, that earlier-later relations constitute time, and passage is an illusion, is a feature of our temporal perspective, and the universe exists as a four-dimensional block, a block universe where all times are equally real, and past, present, and future are not objective features of reality, but are indexical, are relative to a perspective, and this B theory has become orthodoxy in philosophy of time, is widely accepted as avoiding McTaggart's paradox while preserving the reality of time. Another response, the tense or A theory response, denies that the A series is contradictory, argues that McTaggart's argument involves a mistake, that A series properties are not really contradictory because they are indexed to times in a non-problematic way, and the meeting being future at t1 and past at t2 is not contradictory, is just the normal way temporal properties work. And A theorists argue that passage is real, that the present is objectively real, that the future is open and the past is fixed. And McTaggart's argument fails because it assumes that A series properties must be simultaneous to be contradictory when they are not simultaneous, are at different times, and this response preserves the A series, preserves passage, and rejects McTaggart's conclusion that time is unreal. A third response from presentism argues that only the present exists, that past and future are unreal, and so events do not have contradictory A-series properties because only present events exist, and only present properties are real, and the meeting is not simultaneously past, present, and future because only one of these is real at any time. And presentism avoids McTaggart's paradox by radical ontological restriction, by accepting that most of time does not exist, and this preserves the reality of the present, preserves passage, but faces difficulties explaining how truths about past and future can be true if past and future do not exist. McTaggart's paradox has been enormously influential, has shaped all debates about time, has forced philosophers to clarify their positions, to distinguish A theories from B theories, to recognize that different conceptions of time have different metaphysical commitments, and the paradox remains controversial, remains debated, with some accepting McTaggart's conclusion that time is unreal, some accepting that the A series is contradictory, but denying that this makes time unreal, and some denying that the A series is contradictory, and no consensus exists, and the paradox endures as one of the most important arguments in metaphysics, an argument that challenges our ordinary understanding of time, forces recognition that temporal passage, the movement from future through present to past, is philosophically problematic, and whether time is real or illusory remains one of philosophy's deepest questions. And McTaggart's paradox continues to structure the debate, continues to force philosophers to grapple with the nature of time, with whether passage is objective or subjective, with whether reality is a static four-dimensional block or a dynamic unfolding present, and the paradox persists, unsolved and perhaps unsolvable, a permanent challenge to theories of time. Morton's fork, when both choices lead to the same doom. A tax collector in 15th century England faces a dilemma when assessing how much wealthy citizens should pay, and the collector observes that some nobles live extravagantly, displaying their wealth openly, and others live frugally, claiming poverty. And Archbishop John Morton, serving as Lord Chancellor under King Henry VII, devises a strategy to extract taxes regardless of which lifestyle the noble chooses, and the strategy is simple and brutal. If a noble lives extravagantly, then clearly they have money and can afford to pay high taxes. And if a noble lives frugally, then clearly they are saving money and must have accumulated wealth and can afford to pay high taxes. And either way, the noble must pay. There is no escape, no strategy that avoids taxation. And this trap, where two apparently opposite choices lead to the same unwanted outcome, became known as Morton's fork, named after the archbishop who wielded it, and the term has entered common usage to describe any situation where someone must choose between two options that both lead to the same undesirable result, where the appearance of choice masks the reality of inevitability. Imagine being a noble in Morton's England, weighing your options, trying to decide whether to live well or live simply, and realizing that either choice leads to heavy taxation, that the tax collector has closed off all escape routes, has constructed a logical trap where your strategy is irrelevant, where you lose regardless of what you choose. And this creates a sense of futility, a recognition that the game is rigged, that the appearance of agency is illusory. And Morton's Fork exemplifies a class of situations where apparent choices are not genuine choices, where different paths converge on the same destination, and the only real choice is whether to accept the inevitable or to refuse to play the game at all. The structure of Morton's Fork appears throughout logic, rhetoric, and strategy. Wherever someone constructs an argument that covers all cases, that shows that regardless of what premises are accepted, a certain conclusion follows, and such arguments can be powerful tools of persuasion, can trap opponents in positions where they cannot escape the conclusion, but they can also be fallacious, can hide implicit assumptions or false dichotomies, can present apparent inevitability that dissolves under scrutiny. And distinguishing genuine Morton's Forks from apparent ones requires careful analysis of whether the two paths really do lead to the same conclusion, or whether there are hidden differences, hidden escape routes. Visualize the fork as a Y-shaped path, two branches diverging, one path representing extravagance and one representing frugality, and both paths lead to the same destination. The tax collector's office and the noble walking either path arrives at the same place. And the fork is not a choice between outcomes, but a choice between routes to a predetermined outcome. And the futility comes from recognizing that movement, that action, that strategy, all are pointless, all lead to the same end, and the only way to avoid the destination is to refuse to walk, to opt out of the entire framework. Morton's Fork differs from a dilemma, where two choices lead to different, undesirable outcomes, and the chooser must select the lesser evil, because in Morton's Fork, the outcomes are the same, are equally bad, and the choice is between different routes to that bad outcome. And this makes Morton's Fork particularly frustrating, particularly demoralizing, because at least in a dilemma there is a meaningful choice, a decision that matters, but in Morton's Fork the choice does not matter. The outcome is fixed, and the appearance of choice is a cruel illusion. The concept has applications in game theory, in situations where a player's strategies are dominated, where regardless of what the player does, the outcome is worse than some alternative the player cannot access, and recognizing Morton's Forks is important for strategic reasoning, for understanding when continued play is pointless, when the game should be abandoned rather than played, because playing only wastes resources without changing the outcome. Morton's Fork also appears in legal and political contexts, where laws or policies are designed to be inescapable, where any action a person takes falls under the law's scope, and this can be legitimate, can reflect comprehensive regulation of a domain, but it can also be oppressive. It can create situations where individuals have no legal way to avoid a burden, no option but compliance, and recognizing such structures is important for identifying injustice, for understanding when law has become a trap rather than a framework for freedom. The paradox also has psychological dimensions, because facing Morton's Fork creates learned helplessness, creates the sense that choices do not matter, that outcomes are predetermined regardless of effort or strategy, and this can lead to resignation, to ceasing to resist, to accepting the inevitable, and oppressive systems often work by creating Morton's Forks, by ensuring that resistance and compliance lead to similar outcomes, that fighting and surrendering are equally futile, and breaking out of Morton's Fork requires either finding a hidden third option, a way to refuse the binary choice, or accepting one path and finding meaning in the choosing, even if the outcome is fixed. Some philosophers argue that life itself is Morton's Fork, that all paths lead to death, that whether we live virtuously or wickedly, happily or miserably, we end up in the same place, non-existent, and this can be a source of nihilism, can undermine the sense that choices matter, but it can also be liberating, can free us to choose based on values rather than outcomes, to recognize that If all paths lead to death, then what matters is the path itself, the journey, not the destination, and Morton's Fork becomes an invitation to find meaning in process rather than result. The Archbishop's strategy was effective, was brutal, extracted taxes efficiently, and the nobles paid, unable to escape the logic, unable to find a strategy that avoided the fork. And Morton's Fork entered history, became a term of art, became a warning about inescapable traps, about situations where apparent choice conceals actual constraint, and the fork remains present in contemporary debates about policy, law, and strategy. A reminder that not all choices are meaningful, that sometimes the appearance of freedom masks the reality of compulsion, and that recognizing Morton's Fork is the first step toward escaping it, toward finding the third option, the refusal to engage, the rejection of the binary. And the fork stands, points in two directions, both leading to the same place, and the challenge is to see the fork for what it is, to recognize when choice is illusory, when strategy is futile, and when the only real option is to walk away, to refuse the fork entirely, to create a new path that the fork's designer did not anticipate. And Morton's Fork remains a timeless trap, a logical structure that appears whenever someone seeks to eliminate all escape routes, to ensure that whatever choice is made, the desired outcome follows. And the fork endures as a reminder that the appearance of choice can be deceptive, that freedom requires more than options, requires that options lead to genuinely different outcomes, and that when options converge, when the fork's prongs meet, choice becomes meaningless, and only opting out restores agency. Parfit's teletransportation paradox. Imagine a future where technology allows instant travel across vast distances through a process called teletransportation. A device scans your body down to the atomic level, recording the exact position and state of every particle, and then transmits this information to a distant location where another device reconstructs you perfectly, assembling a body atom by atom according to the transmitted blueprint. And the reconstruction is flawless, every memory intact, every scar reproduced, every thought continued, and the reconstructed person steps out of the receiving chamber, believing themselves to be you, feeling no discontinuity, no sense that anything strange has occurred. The philosopher Derek Parfit asked a disturbing question about this process. Are you the person who steps out of the receiving chamber, or did you die in the scanning chamber? And a copy, a duplicate with all your memories and personality, is now living your life. And if the scanning process destroys the original body as it records the information, then perhaps it is still you, continuous in some sense. But what if the original body is not destroyed? What if the scanner leaves you standing in the departure chamber, intact and alive, while the reconstruction appears in the receiving chamber? And now there are two of you, both with equal claim to being the original, both feeling that they are you, and if both are you, then identity has become plural. But if only one is you, then which one and what criterion could possibly distinguish them when they are physically and psychologically identical? Parfit used this thought experiment to challenge the intuition that personal identity is what matters in survival, arguing that what matters is not identity, not being numerically the same person, but rather psychological continuity and connectedness, the preservation of memories, personality, beliefs, desires, and ongoing projects. And if these are preserved, then survival has occurred even if strict identity has not. And so, the reconstructed person is you in every way that matters, even if they are not numerically identical to the original you. And the question of whether identity is preserved is a question about what we care about rather than a deep metaphysical fact. The paradox becomes more troubling when variations are introduced. Suppose the teletransportation device malfunctions and creates not one, but two reconstructions, both perfect, both claiming to be you, and now identity must branch, which seems impossible because identity is supposed to be a one-to-one relation, A thing is identical only to itself, and yet both reconstructions have an equal claim. And if identity is not preserved in this case, then why should it be preserved in the normal case where only one reconstruction appears? And if it is not preserved, then every time you use the teletransporter, you die, and a new person with your memories takes your place, living a life they falsely believe is a continuation of yours. Parfit embraced the conclusion that identity is not what matters, that we should care about psychological continuity rather than numerical identity, and that the concept of a persisting self, a single unified person who endures over time, is less important than we ordinarily think. That what makes your future self matter to you now is not that they are literally the same person, but that they are psychologically connected to you in the right ways, and if those connections can branch or spread across multiple individuals, then so be it. Identity is not sacred, not the ultimate ground of value or concern. The teletransportation paradox has implications for how we think about personal survival, about whether what matters in death is the cessation of psychological continuity or the cessation of biological life, about whether uploading consciousness to a computer or creating digital copies would constitute survival or merely the creation of simulacra, and about whether the self is a metaphysical entity or a convenient fiction we use to organize experience. The paradox also challenges intuitions about moral responsibility, because if identity is vague or plural, then questions about who is responsible for past actions or who deserves future rewards become murky, and the unity of the person, which underpins much of ethics and law, begins to dissolve. Parfit's teletransportation scenario remains one of the most powerful thought experiments in philosophy, a story that uses imaginable technology to expose deep questions about identity, survival, and what it means to be a person, forcing recognition that the boundaries of the self, like the boundaries of clouds and cats, may be far less clear and far less important than common sense suggests, and that the question of whether you survive. Teletransportation may have no determinate answer, or many answers, or may simply be the wrong question to ask. Schrödinger's cat, the pet that's both alive and dead. A cat sits in a sealed box, a box that cannot be opened or observed from the outside. And inside the box with the cat is a device, a quantum mechanism that has a 50% chance of killing the cat within 1 hour and a 50% chance of leaving the cat alive. Perhaps a vial of poison that will break if a single radioactive atom decays. And the decay is a quantum event, genuinely random, with no way to predict whether it will happen in the next hour. And so after 1 hour has passed, the cat is either alive or dead. 50-50 odds. And this seems straightforward, but the paradox emerges when quantum mechanics is taken seriously, when the rules of quantum theory are applied consistently, because quantum mechanics says that before a measurement is made, before the box is opened and the cat is observed, the system exists in a superposition, a combination of both possible states simultaneously. And so the cat is both alive and dead at the same time, existing in a strange limbo where neither state is definite until observation collapses the superposition and forces the system into one state or the other. And this is Schrödinger's cat, a thought experiment devised by physicist Erwin Schrödinger in 1935 to illustrate what he saw as the absurdity of applying quantum mechanics to macroscopic objects to show that something was wrong with the standard interpretation of quantum theory. Imagine the situation step by step. At the beginning, the cat is alive, the radioactive atom has not yet decayed, and the quantum state is well defined. But as time passes, the atom enters a superposition of decayed and not decayed, because quantum mechanics describes it with a wave function that assigns amplitudes to both possibilities, and these amplitudes evolve smoothly, and the atom is in a state of quantum indeterminacy, neither definitely decayed nor definitely not decayed, until a measurement is made. And this indeterminacy is not ignorance, not a matter of the atom being in one state or the other, and we just do not know which, but a genuine feature of quantum reality. The atom literally does not have a definite state until measured. And because the poison release is coupled to the atom's state, the poison is both released and not released. And the cat is both dead and alive, existing in a superposition of macroscopic states. And this conclusion seems absurd, seems to violate everything we know about cats and boxes and life and death. And Schrödinger intended it to be absurd, to show that something must be wrong with the orthodox interpretation of quantum mechanics, that the theory cannot be applied consistently to large objects, that there must be a boundary somewhere between the quantum realm, where superpositions occur, and the classical realm, where objects have definite states. The paradox has generated an enormous amount of discussion and debate in physics and philosophy, with different interpretations of quantum mechanics offering different resolutions. The Copenhagen interpretation, the dominant view in Schrödinger's time, says that the wave function collapses upon measurement, that the act of observation forces the system into one definite state. And so when the box is opened and the cat is observed, the superposition collapses and the cat becomes definitely alive or definitely dead. But this raises questions about what counts as a measurement, about what constitutes an observer, about whether consciousness is required to collapse the wave function, or whether any physical interaction suffices. And these questions remain controversial, and the Copenhagen interpretation does not provide clear answers, does not specify where the quantum classical boundary lies. The many worlds interpretation offers a different resolution, saying that the wave function never collapses, that both outcomes occur, that the universe splits into two branches, one where the cat is alive and one where the cat is dead, and both branches are equally real. And the observer also splits, becoming two versions, one observing a live cat and one observing a dead cat. And each version believes they have observed a definite outcome. But from a global perspective, both outcomes happen. And the superposition is resolved not by collapse but by branching. And this interpretation avoids the measurement problem, avoids the need to specify what counts as a measurement. But it introduces other difficulties: the proliferation of parallel worlds, the question of what it means for both outcomes to be real, and whether this is a genuine solution or merely a reformulation of the problem. Decoherence theory provides another perspective, focusing on the interaction between the quantum system and its environment. And it shows that macroscopic objects, like cats, are constantly interacting with their surroundings, with air molecules, with photons, with thermal radiation, and these interactions cause the quantum coherence, the delicate phase relationships that allow superpositions to be destroyed very rapidly in a fraction of a second for macroscopic objects. And once coherence is lost, the system behaves classically, appears to be in one definite state, and so the cat never actually exists in a superposition of alive and dead, or exists in such a state for only an immeasurably short time before decoherence converts it to a classical mixture, a probabilistic state where the cat is either alive or dead. We just do not know which until we look. And this dissolves the paradox by denying that macroscopic superpositions persist long enough to be observable. The paradox also raises questions about the role of consciousness in quantum mechanics, about whether an observer must be conscious to collapse the wave function, and some interpretations suggest that consciousness plays a special role, that the cat remains in superposition until a conscious being opens the box and perceives the outcome. And this view has been criticized as mystical, as importing mind into physics in ways that are unnecessary and unhelpful. And most physicists reject it, preferring interpretations that treat measurement as a physical process involving interactions with macroscopic devices, not requiring consciousness. But the question remains open, debated, unresolved, and Schrödinger's cat sits at the center of this debate, a symbol of the deep puzzles that quantum mechanics presents. Visualize the box, sealed and opaque, and inside the cat waits, and the quantum device ticks, and the atom hovers in superposition. And according to quantum mechanics, the entire contents of the box, the atom, the device, the poison, the cat, all exist in a superposition of two macroscopically distinct states: alive, cat no decay, and dead cat decay. And this superposition is described by a wave function that smoothly evolves. And the two branches of the wave function correspond to two different realities. And yet before the box is opened, there is only one box, one cat, one system. And the paradox is that quantum mechanics seems to say the cat is both alive and dead. While common sense says the cat is either alive or dead, we just do not know which. And this clash between quantum formalism and classical intuition is the heart of Schrödinger's cat, a paradox that has no agreed-upon solution, that different interpretations resolve in different ways, and that continues to drive research in the foundations of quantum mechanics. In efforts to understand what measurement means, what quantum states represent, and how the quantum world relates to the classical world we experience, the box sits on the table, the hour passes, and the cat's fate is sealed. Or is it? Or is the cat in limbo, suspended between life and death, waiting for observation to make reality definite? And the paradox endures, not because physicists do not understand quantum mechanics, but because quantum mechanics, understood correctly, leads to conclusions that seem impossible, that violate everyday experience, that force choices between interpretations that are empirically equivalent but conceptually divergent. And Schrödinger's cat remains the most famous illustration of this strangeness, a thought experiment that has entered popular culture, a paradox that symbolizes the weirdness of quantum reality. And the cat, alive and dead, real and hypothetical, continues to haunt physics and philosophy, a permanent reminder that the quantum world is not merely different in degree from the classical world, but different in kind, governed by rules that defy visualization and resist intuitive understanding. And the paradox persists, unresolved in the deepest sense, a puzzle that reveals the limits of human intuition and the challenge of making sense of a theory that works perfectly in practice but remains mysterious in principle. The Achilles and the tortoise. Achilles, the swift-footed hero of Greek legend, agrees to race a tortoise, and to make the contest fair, the tortoise is given a head start, perhaps 100 meters, and the race begins, and Achilles runs swiftly toward the point where the tortoise started. But by the time he reaches that point, the tortoise has moved forward a small distance, perhaps 10 meters, and so Achilles runs toward that new position. But again, by the time he arrives, the tortoise has advanced a bit further, perhaps 1 meter, and this process continues. Each time Achilles reaches where the tortoise was, the tortoise has moved ahead. And it seems that Achilles can never quite catch up, never quite overtake the slower creature. And yet common sense insists that, of course, Achilles will pass the tortoise. That speed wins races, that the faster runner always overtakes the slower, given enough time and distance. And this contradiction between logic and intuition is Zeno's most famous paradox, a puzzle that has captivated philosophers and mathematicians for over 2 millennia. Zeno of Elea constructed this argument in the 5th century BCE as part of his defense of Parmenidean monism, the idea that reality is one unchanging whole and that motion and plurality are illusions. And the paradox was meant to show that the concept of motion leads to absurdity, that if we accept that space and time can be divided infinitely, then the faster can never overtake the slower. And since this conclusion is obviously false, something must be wrong with our assumptions about motion and change. The paradox rests on the idea that Achilles must complete infinitely many tasks, reaching the first point where the tortoise was, then the second, then the third, and so on without end. And if each task takes some amount of time, however small, then infinitely many tasks would require infinite time. And yet in reality, Achilles catches and passes the tortoise in a finite time. And so where is the error? Aristotle argued that the paradox confuses potential and actual infinity, that while the path can be divided into infinitely many segments in thought, Achilles does not actually perform infinitely many separate actions. He simply runs, continuously and smoothly, and the infinite division is an artifact of analysis, not a feature of the motion itself. The resolution became clearer with the development of calculus, which showed that an infinite series of diminishing intervals can sum to a finite total, that 1 plus 1/10th plus 1/100th, and so on converges to a specific finite value. And so the infinite number of time intervals Achilles requires to reach each successive position also sum to a finite time, the time it takes him to overtake the tortoise. Yet the paradox retains a strange power, a sense that something about infinity remains counterintuitive, that the idea of completing an infinite number of steps feels impossible, even when mathematics insists it is not, and philosophers continue to debate whether the mathematical resolution truly captures the conceptual problem or merely sidesteps it. The paradox also connects to questions about the nature of space and time, whether they are continuous or discrete, whether motion is genuinely smooth or composed of tiny jumps, whether there is a smallest possible distance or duration beyond which reality cannot be divided. And these questions remain open in modern physics, where quantum mechanics and theories of spacetime suggest that the classical picture of smooth continuous motion may break down at the smallest scales. If you enjoy these explorations of paradox and the limits of thought, consider subscribing so you never miss a journey into philosophy's most perplexing puzzles, and perhaps leave a comment sharing where you are in the world as you listen to these ideas unfold. Achilles and the tortoise remain locked in their eternal race, a metaphor for the human attempt to reconcile the finite with the infinite, the continuous with the discrete, the logical with the intuitive. And the paradox endures as a reminder that even the simplest motion, a hero chasing a tortoise, conceals within it mysteries that have not been fully solved. Questions that linger at the boundary where mathematics meets reality, where reason meets experience, where what must be true, according to logic, clashes with what obviously is true, according to the world. The bald man paradox. A man stands before a mirror, his hair full and thick, and no one would call him bald, this much is certain. And yet time passes, and hairs fall, one by one, slowly at first and then with gathering speed. And the question that haunts philosophers is simple and unanswerable. At what precise moment does this man become bald, after which single hair crosses the threshold from not bald to bald? And the intuition rebels against the idea that one hair could make such a difference, that the removal of a single strand could transform a person's category, could change a truth about them in such a fundamental way. The bald man paradox is a version of the Stoic's paradox, focused specifically on baldness, but illustrating the same underlying problem about vagueness, boundaries, and the limits of classification. And it asks us to consider whether baldness admits of sharp boundaries, or whether it is inherently vague, a matter of degree rather than kind. And if it is vague, then how can we use the term meaningfully? How can we say that someone is bald or not bald when there seems to be no clear line separating the two states? Imagine the process in reverse, starting with a completely bald man, hairless and smooth, and now a single hair appears on his head, and surely one hair does not make him not bald. The presence of a single hair is negligible, imperceptible to casual observation, and if one hair does not change baldness, then neither does two, and if two do not, then neither does three, and this reasoning continues, step by step, until the man has a full head of hair, and yet according to the logic he should still be bald because no single hair made the difference, and this conclusion is absurd, and so something must be wrong with the reasoning, but what? The paradox forces a choice between several uncomfortable positions. One option is to accept that there is a sharp boundary, a precise number of hairs that separates bald from not bald. perhaps 10,000 hairs or 5,000 or some other specific number. And anyone with fewer hairs than this threshold is bald, while anyone with more is not bald. And this view preserves classical logic, maintains that every statement is either true or false, that vagueness is merely epistemic, a matter of our ignorance about where the true boundary lies. But this position strikes many as implausible because it seems arbitrary. There is no principled reason why 10,000 hairs should be the cutoff rather than 10,001, and the idea that baldness depends on such a precise count feels wrong, disconnected from how we actually use the term. Another option is to reject the idea of sharp boundaries and embrace the view that baldness is genuinely vague, that there are borderline cases where it is neither determinately true nor determinately false that someone is bald, cases where the world itself does not settle the question. And this view requires abandoning or modifying classical logic, accepting that by valence, the principle that every proposition is either true or false does not hold for vague predicates, and this leads to various non-classical logical systems. Three-valued logics where propositions can be true, false, or indeterminate, fuzzy logics where truth comes in degrees ranging continuously from 0 to 1. Supervaluationism, where a statement is true if it is true on all acceptable ways of making the vague term precise, and each of these approaches has costs and benefits. Each preserves some intuitions while sacrificing others. A third option is contextualism, the view that whether someone is bald depends on the context of utterance, on the standards and purposes operative in a given conversation or situation. And in one context, a man with 5,000 hairs might count as bald, while in another context only someone with fewer than 1,000 hairs would count. And this view makes baldness relative rather than absolute. And it explains why borderline cases feel uncertain, because in borderline cases the context has not provided enough information to determine which standards apply, but contextualism faces challenges too. It must explain how context determines standards, whether there are constraints on what standards can be operative, and whether contextualism avoids the Stoic paradox or merely relocates it to the question of when contexts shift. The bald man paradox also connects to broader questions about language, reference, and the relationship between words and the world. Because if most predicates in natural language are vague, and they are, nearly every adjective and many nouns admit of borderline cases, then vagueness is not a peripheral issue, but a central feature of how we communicate. And any theory of meaning must account for it, must explain how. Vague terms can be useful and informative despite their lack of sharp boundaries, and must address whether vagueness is a feature of language, of thought, of the world, or of all three. Some philosophers argue that vagueness is purely linguistic, that the world itself is precise and determinate, but our words are blunt instruments that fail to carve reality at its joints, while others suggest that vagueness exists in thought as well, that our concepts are themselves fuzzy, and still others propose that the world itself contains vague objects and properties, that reality does not always come with sharp boundaries, that nature is continuous and gradual in ways that resist precise classification. The paradox has practical implications as well. In law, where terms like reasonable and substantial and significant must be applied to real cases despite their vagueness. In medicine, where diagnostic criteria often involve thresholds that are somewhat arbitrary. In ethics, where drawing lines between permissible and impermissible actions may require confronting borderline cases where intuition provides no clear guidance. And in each of these domains, the bald man paradox is not merely an abstract puzzle, but a genuine obstacle to clear thinking and fair judgment. The paradox also raises questions about personal identity and change over time. Because if baldness is gradual, then so are many other properties, aging, growing, learning. And if there are no sharp transitions, then perhaps personal change is also vague. Perhaps there are cases where it is indeterminate whether someone is the same person they were years ago, whether they have changed in significant ways or remained essentially the same. And this connects to deeper issues about persistence, continuity, and what it means to endure through time. The bald man stands as a symbol of all borderline cases, all situations where reality resists the either-or structure of classical logic, where predicates fade gradually from clear application to clear non-application, passing through a twilight zone where truth becomes uncertain. And the paradox endures because it exposes a tension between the precision we expect from rational thought and the vagueness inherent in the world and in language. And no solution has won universal acceptance. Philosophers continue to debate whether to accept sharp boundaries, revise logic, relativize truth to context, or adopt some more radical approach. And the bald man remains poised between categories. Neither clearly bald nor clearly not bald in the borderline cases, a living embodiment of the limits of definition, a reminder that the world does not always cooperate with our desire for clarity, and that some questions may have no determinate answer, not because we lack knowledge, but because the questions themselves presuppose a precision that reality does not provide. And the hairs fall one by one, and baldness approaches, and no single hair marks the moment of transformation, and the paradox persists, unresolved and perhaps unresolvable, a permanent feature of the conceptual landscape we must navigate, a crack in the foundations of logic that cannot be sealed. The Bertrand's box paradox. 3 identical boxes sit before you, each containing 2 coins. The first box contains 2 gold coins, the second box contains 2 silver coins, and the third box contains 1 gold coin and 1 silver coin. And you cannot see inside the boxes, cannot distinguish them from the outside. And a box is chosen at random and opened, and 1 coin is drawn from it, also at random, and the coin turns out to be gold. And now a question is posed that seems simple, but leads to surprising confusion. What is the probability that the other coin in the same box is also gold? And the intuitive answer that most people give is 1/2, reasoning that since the drawn coin is gold, the box cannot be the one with 2 silver coins. So it must be either the box with 2 gold coins or the box with 1 gold and 1 silver. And these 2 possibilities seem equally likely, and so the probability that the other coin is gold should be 1/2. But this reasoning is wrong. The correct answer is 2/3, and this is Bertrand's box paradox, named after Joseph Bertrand, who presented it in 1889, a puzzle in conditional probability that reveals how easily intuition misleads when reasoning about random processes and conditional information. The error in the intuitive reasoning lies in treating the 2 remaining boxes as equally likely, but they are not, because the probability calculation must account for how the gold coin was observed, must condition not just on which box was chosen, but on which coin was drawn. And the key insight is that there are 3 gold coins in total, 2 in the first box and 1 in the third box, and the drawn coin is equally likely to be any of these 3. And if the drawn coin is one of the 2 from the first box, then the other coin in the same box is also gold, while if the drawn coin is the one from the third box, then the other coin is silver. And since 2 of the 3 equally likely possibilities lead to the other coin being gold, the probability is 2/3, not 1/2. Another way to see the solution is to consider all possible outcomes. There are 6 coins in total, labelled gold 1 and gold 2 in the first box, silver 1 and silver 2 in the second box, and gold 3 and silver 3 in the third box. And each coin is equally likely to be the one drawn. And we're told that a gold coin was drawn, which eliminates silver 1, silver 2, and silver 3, leaving gold 1, gold 2, and gold 3 as equally probable. And if gold 1 was drawn, then the other coin in the same box is gold 2. If gold 2 was drawn, then the other coin is gold 1. And if gold 3 was drawn, then the other coin is silver 3. And so in 2 of the 3 cases, the other coin is gold, giving a probability of 2/3. The Bertrand box paradox is structurally similar to other probability puzzles, like the Monty Hall problem and the three prisoners problem, where conditioning on partial information updates probabilities in non-obvious ways, where the process by which information is revealed matters as much as the content of the information, and where naive intuition fails to properly account for the structure of the problem, and the paradox illustrates the importance of specifying the sample space carefully, of identifying all possible outcomes and their probabilities, and of using Bayes' theorem or other formal tools to update probabilities rather than relying on informal reasoning. The paradox also raises questions about the reference class problem, about which population of events the observed outcome should be considered a member of, because the intuitive error involves thinking of the outcome as selecting a box type, either 2 gold or mixed, rather than selecting a particular coin, and this shift in reference class changes the probabilities, and the correct solution requires identifying the right reference class, the set of all coins that could have been drawn, and calculating probabilities relative to that set. Bertrand's box paradox has pedagogical value. It is often used in teaching probability to illustrate conditional probability, to show how careful reasoning differs from intuitive judgment, and to demonstrate the value of systematic methods like constructing probability trees or using Bayes' theorem, and students who understand the paradox gain insight into a common class of errors that arise from failing to properly condition on all relevant information, from treating distinct events as equiprobable when they are not, and from confusing the probability of a hypothesis given evidence with the probability of evidence given a hypothesis. The paradox also appears in variations, sometimes with coloured balls instead of coins, sometimes with different numbers of boxes or different distributions, and each. Variation tests slightly different aspects of probabilistic reasoning, but the core lesson remains the same, that conditional probabilities must be calculated carefully, that intuition is unreliable, and that formal methods are necessary to avoid systematic errors. And the paradox connects to real-world situations where similar reasoning is required. Medical diagnosis, where symptoms must be interpreted in light of disease prevalence and test reliability. Legal reasoning, where evidence must be weighed in light of prior probabilities and alternative explanations. And machine learning, where classifiers must be trained to properly account for base rates and conditional dependencies. The boxes sit on the table, indistinguishable from the outside. The gold coin gleams in your hand, and the question hangs in the air: what is the probability that the other coin is also gold? And the answer, 2/3, contradicts the intuitive 1/2, and the gap between intuition and mathematics reveals something about how we reason about chance, about how we estimate probabilities, about how we update beliefs in light of evidence. And the Bertrand box paradox remains a touchstone, a simple puzzle with a surprising answer, a demonstration that probability is subtle, that conditioning changes things in non-obvious ways, and that even questions that seem straightforward can hide complexity, can require careful analysis to answer correctly. And the paradox endures as a teaching tool, a cautionary tale, a reminder that mathematical reasoning is necessary to avoid errors that intuition cannot prevent. And the gold coin sits there, evidence that shifts probabilities, information that updates beliefs, and the calculation proceeds, formal and precise, yielding 2/3, and the intuition retreats, humbled by mathematics, corrected by careful thought, and the lesson is learned again, that probability is counterintuitive, that conditional reasoning is hard, and that paradoxes like Bertrand's box serve an essential function, exposing the gaps between how we think we reason and how we actually should reason, between the quick judgments of intuition and the slow calculations of mathematics. And the boxes remain coins inside, waiting to teach the next student, to confound the next intuition, to reveal once more that chance and evidence interact in ways that defy expectation. And the paradox persists, elegant and instructive, a permanent fixture in the pedagogy of probability, a puzzle that generations of students have encountered and been surprised by, and will continue to encounter as long as probability is taught and intuition needs correction. The card paradox. Imagine a card, simple and rectangular, lying flat on a table, and on one side is written a single sentence. The statement on the other side of this card is true, and already the mind begins to sense danger, a trap being set. The card is flipped over, and on the reverse side another sentence appears. The statement on the other side of this card is false, and now the contradiction is complete. A perfect loop of mutual negation that cannot be resolved no matter how many times the card is turned. If the first side is true, then the second side must be true, as the first side claims, but if the second side is true, then the first side must be false, as the second side claims, which contradicts the assumption that the first side is true. And if the first side is false, then the second side must be false, as the first side incorrectly claims it is true. But if the second side is false, then the first side must be true, as the second side incorrectly claims it is false, and the cycle spirals endlessly without rest. The card paradox is a variation of the liar paradox, but its physical form makes the contradiction feel more tangible, more concrete, a paradox that can be held in the hand and turned over and over, as if repetition might somehow reveal a hidden answer that logic cannot provide. The paradox demonstrates how self-reference can be distributed across multiple statements rather than contained in a single sentence, showing that contradictions do not need to be immediate or obvious to be genuine, that they can emerge from relationships between statements rather than from the statements themselves. Philip Jourdan, a mathematician and logician, is often credited with popularizing this version of the paradox in the early 20th century, using it to explore the limits of truth and reference, and to illustrate the kinds of problems that plagued attempts to formalize logic and mathematics during that era. The card paradox also reveals something about the nature of truth itself, the way that truth is not a property that statements possess in isolation, but a relationship between statements and the world, or between statements and other statements. And when those relationships form closed loops, the concept of truth begins to break down. Some philosophers argue that the statements on the card are neither true nor false, but meaningless, that they fail to refer to anything outside themselves, and therefore do not qualify as genuine propositions, while others suggest that the paradox exposes a flaw in the classical assumption that every statement must be either true or false, that perhaps some statements occupy a third category, undefined or indeterminate. The card sits on the table, innocent and menacing, a small object that contains an infinite problem, and no amount of flipping will resolve what is written on its surfaces. No clever interpretation will untangle the knot, and so it remains, a monument to the limits of language and logic, a reminder that not all questions have answers, that some truths are forever out of reach, caught in loops that reason cannot break.